Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. In the previous video, we derived the IV estimator and we noted that beta IV, or beta hat IV, the actual estimation, is equal to sigma 1 hat over pi 1 hat. Now let's see in action with a concrete numerical example, going through each step and seeing exactly why the causal effect is recovered by doing the IV estimation. Let's start with a research question. Let's say that we want to estimate whether education increases earnings. So, does education increase earnings? So we're gonna take our y variable as earnings. Let's say annual earnings in thousands of pounds. We're going to have X as years of education. And we have Z, which is distance to nearest uni, and that could be in kilometers. Let's assume that education is endogenous, because let's say ability and motivation both affect education and earnings, and expected earnings may influence how long someone stays in education. So OLS cannot clearly separate these effects, and that's why we use distance as the instrumental variable. Now, keep in mind, we've talked about this in previous videos as well. Distance satisfies relevance because people closer to uni tend to get more education. It also satisfies the exclusion argument because distance affects earnings only through education, so not directly, at least we don't think it's possible otherwise, as discussed in previous video 7 as well. So we are going to first estimate education equals to pi 0 plus pi 1 distance plus some error term v. And let's assume for now that the result of this estimation is actually education hat equals to 10 minus 0.02 distance. Okay, so technically what we're seeing in here is that every additional kilometer from the nearest university reduces education by 0.2 years on average. And let's assume also that this is statistically significant, making our relevance check relevant, basically. So the instrument moves the endogenous variable as required. Keep in mind, in a real application, you check the first stage F statistic, okay? Now, let's go to the reduced form. So this would have been stage 1 of the IV. Instead of going directly to stage 2, we're going to look at the reduced form. If you remember, the reduced form is earnings. So the y variable directly into our instrument. So sigma 0, sigma 1, distance, and let's say some error term u. Let's assume that the estimation that we got is earnings equal to 60 minus 0.6 times distance. So what we've found here is that every additional kilometer from the nearest university reduces annual earnings by 16 on average. Now, a question that might come to you is, why does distance actually reduce earnings? Because we have a negative coefficient in here. And is it because people who live further away earn less directly, or because they get less education, which then reduces earnings? The thing is, the reduced form can't answer the question by itself, okay? So can't answer by itself. ultimately, remember, we're looking for instrumental variables that affect the y only through x. So that's what exactly IV is for. Both coefficients, also notice, in this particular case, they are both negative, okay? So distance reduces both education and earnings. That's consistent with the instrument working as expected. If the signs were inconsistent, that would be a warning sign. Now, let's apply the Wald estimator. So we know both of the estimations. We've got pi 1 hat, which was minus 0.2, sigma 1 hat, which is 3, minus 0.6, getting ahead of myself here. So if we compute the beta IV hat, that will clearly show sigma hat over pi 1 hat, which will give us exactly 3. Okay? So the negatives have canceled out. The IV estimate is positive as we expected. And from here, we can say that one additional year of education increases annual earnings by £3,000, because remember, this was in £1,000. So overall, you always have to make sure you check the signs in case they make economic sense. Here, both the reduced form and first stage are negative. Distance reduces both education and earnings, so their ratio is positive. If the signs were mixed without a good reason, that would obviously warrant an investigation. Okay. In terms of interpretation, so again, we will say one additional year of education increases our annual earnings by approximately £3,000. But be precise about what this means in general, okay? So keep in mind, we're not comparing everyone with different education levels. So that comparison is contaminated by ability, motivation, and family background. So we are comparing people whose education differs because of how far they lived from a university. And I think this is a very crucial point that a lot of students sometimes miss and don't see. So let me write that down. We are comparing people whose education differs because of how far they lived from uni. Okay? So this beta IV being 3 is the causal effect of education on earnings for people whose schooling was influenced by distance. This is also what we call the LATE, so the local average treatment effect. So IV recovers the causal effect for the subset of people whose behavior was actually changed by the instrument. So not necessarily for everyone. But we'll return to this concept in the OLS versus IV video. I hope this example was useful for you. In the next one, we'll very quickly show where did OLS go wrong and how should the flow would have gone here so that we can make even more sense about the numbers that we saw in this exercise. I hope this was helpful and stay tuned until the next one.